Good morning. For those of you that will not be in class today, I thought I'd make a video for the lesson. We're going to be finding the equations of planes, and in order to do that, we first have to learn how to find the cross product of two vectors. We found the dot product earlier. The result is a scalar. When you find the cross product, you find another vector that is orthogonal to those two vectors. The cross product algorithm is very much like finding the determinant of a 3 by 3 matrix. We're going to set up a 3 by 3 matrix where the first row is I, J, K. The second row is the components of the first matrix, and the third row is the components of the second. Remember, when you expand, we're going to expand right now across the first row. When you expand, it's -1 to this position is 1, 1. So it's to the 1 plus 1. Let me try that again. It's going to look like 1 plus 1. And then this element, I, and then I am going to be finding the determinant of the remaining 3, 5, 2, 3. And then it's plus -1. This time, we'll be looking at 1. That position is 1, 2. 1 plus 2 times j. Then I've got these elements. And then finally, plus -1. K is in the position 1, 3. So it's 1 plus 3 K. And then these items are left. Now, at the end of the day, this first one is going to be a positive I times what I get when I find the determinant of this 2 by 2 matrix. It's going to be 9 minus 5. So that leaves me with a -1. This is going to be a negative times j, 6 minus 5. So that is a positive 1. And then we have a -1 to the 4th, or a positive k, 4 minus 1, a positive 1. I have the vector -I, -j, positive k as the direction vector for the cross product of these two vectors that we started with. So we're going to go through that one more time. I'm not going to go through all of the I to the position, the -1 to the position powers. We're just going to simplify this, but I just wanted to quickly review where that all comes from. I start with the first row, ijk. Second row is the first matrix, or first vector. Third row is the second vector. So as I said, this first one, it always ends up, if I'm going to expand across the first row, we're just going to alternate signs. And we're using the matrix 3, -1, 4, -3. We're going to find that determinant. Then we're going to eliminate the column with j, 2, -2, -1, -3. And then finally, I eliminate the k column, 2, -2, 3, -4. I multiply and subtract -9 minus a -4. -9 plus 4. Oops, I have a mistake there because that was a negative here. -9 minus 4, -13i. -6 plus -6, -2, -8. With this negative, I have a plus 8j. -8. This time that's going to be a plus 6, a -2k. So I can leave it in IJK form, or I can write that as -13, 8, -2. Now, one more thing is one of the unit vector. So the magnitude of that vector is going to be 13 squared plus 8 squared, actually -13, and -2 squared. We know when we square that, those are going to be all positive. So the magnitude of this vector is root 237. So the unit vector, -13 over root 237, 8 over root 237, -2 over root 237. Okay, this little practice in finding the cross product of two vectors. Now, writing the equations of planes. In this diagram, again, this is always difficult to show something that is three-dimensional on a two-dimensional piece of paper or smartboard. If you're in class, you would see a physical model of this. The vector, this vector, you can imagine this is a piece of paper representing a plane lying flat on my table in the front of the room. And if I take a pencil and I just stand it perpendicular to that piece of paper, that vector we would say would be normal to the vector that is represented by the 2 points in the plane. First, we're going to call a piece of 0 or P naught, and then we're going to extend to a second point P. We're going to give coordinate points, coordinates to P naught and P, and then we're going to define the direction of that normal vector in component form. Okay, since we have said that that is normal, we know that if I would take the dot product between the normal vector and the vector that is going through the 2 points in the plane, we know that that dot product would be equal to 0. And since we have the, we can find the components of piece of 0 to P, or we can find the component form, yeah. We're going to take A, comma, B, comma, C, that vector, and dot it with, we're going to take x minus x naught, y minus x, y naught, and z minus z naught. So I'm going to write that vector, piece of 0, P, and in vector form, or component form, that's the vector. That's how I'm going to write this vector that is represented as piece of 0, P. Okay. We're using the dot product. Then as you see, we're going to take A times, this is going to be equal to 0, A times x minus x naught, B times y minus y naught plus z times z minus z naught would be equal to 0. So let's go ahead and try this. I've written out for you a 3-step process. Keep in mind for your review, if you need some extra assistance when you're working on your homework. Keep in mind that these are 3 points. Those are not vectors. So the first thing we're going to have to do is to find 2 vectors. I'm going to find the vector HI, and it doesn't matter because you're in algebra, you know it doesn't matter which direction when you're finding the slope, whether you do go this direction to find the slope or this direction for 2 points, it doesn't matter. So I'm just going to go H to I because I can easily see that's from 1 to 3 is 2, -1 to -1 is 0, 2 to 1 is -1. And the second vector I've chosen to write is h to k. H to k, 1 to 2, -1 to 1, 2 to 3. And as we learned earlier, now we're going to take the cross product of those two vectors. I'm going to set that up. I minus j plus k. Oops. Too fast here. So I've got 0 plus 2, 2 plus 1, 2 plus 1. Oops, looks like I wrote that one wrong. That is a mistake there. 2, 1, 0, 2. My notes here. 2. Nope. Now 2 times 2 is not 2, it is 4. So the direction vector for this plane is 2, -3, 4. I'm going to take that and dot it with. Now I take x minus any one of the points. If one of these points had several zeros as its coordinates, that's probably the one I'd choose because I'd have less work in expanding it. It doesn't matter which one, it's going to simplify to the same equation regardless. So I've got 2, -3, 4. I'm going to choose x minus 1. I'm going to work with h, comma y plus 1, comma z minus 2. Remember, the dot product of these two vectors, remember this one is in the plane, this one, the 2, -3, 4 is orthogonal, or excuse me, normal to the plane. So now I expand. 2 times x minus 1, minus 3 times y plus 1, plus 4 times z minus 2 is equal to 0. 2x minus 2 minus 3y minus 3 plus 4z minus 8 is equal to 0. 2x minus 3y plus 4z, I've got -2, -5, -3, and -8, so that's -3. If my leading coefficient were negative, I would probably multiply everything through by -1. Okay, that should be enough for you today. There's one more example. You can check the SMART notes, and then your homework is to work the 3 problems on the worksheet that you can find on my Google site. Thank you.